Hi, friends. So as you can tell, I look a little bit like a tomato because, I'm very pale and I live in a very sunny place and this happens sometimes. Um, but today I wanted to talk to you about something that I think is absolutely fascinating and it really helps give me relativity with my life. And I think about it probably at least once a day, if not more. So, if you're willing, I'd like you to come a little bit on a thought experiment with me. So, look at your current environment. And so obviously the device that you're watching this video on is in that environment, but just everything around you. And everything around you is kind of interacting in a sense because it's interacting together to make up your environment. And that includes the physical things like, again, the device that you're watching this on, or if you're sitting, and the thing that you're sitting on, and stuff like that. But it also includes the things that you really can't perceive, like molecules and atoms or fields and stuff like that. Frequencies, like things that you really can't see, like the electromagnetic spectrum or maybe radio spectrum, stuff like that. And so all of these things that are around you, making up your environment right now, they're interacting with one another. And these interactions, even though you may not and humanity may not understand them um, as well as maybe what this thought experiment is going to imply, the fact that they are organized, the fact that they are interacting in an organized manner is, I would argue, pretty undeniable. Um, I'm not saying that you organized it, and I'm not saying that your will or consciousness organized it, even though it may, who knows. But the fact that it's organized at all is just the only thing I want you to kind of keep in mind. Because why do things need to be organized? I mean, it's the stability of inexistence, the stability of nothingness seems way more permanent than the complexity of interaction. And where I'm going with this is no matter what version of history or creation that you believe in, the fact that your reality is organized in a way that allows for you is pretty incredible. No matter what that reality is. So I'll give my view on it, and then hopefully you follow. So I like science a lot. I buy into a lot of things that are published and peer reviewed, and so let's go backtrack to the Big Bang, which is there's some contention over, I suppose, but I would say the majority of the scientific community supports that. And that's not, everyone likes to say the Big Bang, like, oh, everything just happens from a point. No, that's not really what the Big Bang says. The Big Bang just says everything, if you rewind the trajectories that we've observed back far enough, like 13.5 billion years, something like that, they all seem to go to the same point in space time. So that's not saying everything started there, it's just saying everything was there at one point in time if momentum works the way that we think it does. And we have a pretty good idea of how trajectories, velocities, and momentums work. Anyway, so from that point, there was just energy, just so much density and energy that no matter could really coalesce. And then eventually matter starts coalescing and kicking off this whole party called reality, right? So the four things that the mainstream scientific community thus far has boiled down those interactions to are gravity, which is mutual attraction, the electromagnetic force, which is opposite charges attracting to one another, the strong interaction, which is why in the nucleus of atoms greater than hydrogen, that the two protons, which should repel because they're the same, they don't. And so that the reason they don't is because of something called the strong interaction. And then lastly, the weak interaction, or the weak force, and that has to do with decay, but you don't have to really worry about that. But these are the four. And that kick-started all of the complex interaction around us. If you, as big as we think we are, and we are actually quite huge compared to the universe, we're also very, very small. And to kind of give you a view of how that works. So there's something called the Planck length, and the Planck length was derived by measured universal constants, or what we believe are measured universal constants, and these are things like the speed of light, the big G, the attraction of gravity, and there's a few others. And if you remember back to your physics classes, if you can rearrange how these units line up with one another to cancel out units and arrive at an end unit. And there's only one way to rearrange the universal constants that we've measured to leave the last remaining unit of length, to cancel out all the units and leave yourself at a length. And so given the measurements of the constants, of the universal constants, and let's just call this Newtonian physical measurements, there's only one, there's a smallest understandable, we'll call it, there's the smallest length that fits into what we understand. And it's so small. It's incredibly small. It's like 10 to the negative 26th or something crazy small. It's really ridiculously small. However, the Planck length, which again is the smallest unit of length that can be accounted for given our current understanding of Newtonian physics, not quantum, but Newtonian physics, which is pretty much rules everything that you're seeing around you. I'm not saying quantum doesn't play a huge role either, but most of history has been, human history so thus far has been studies of Newtonian physics, which is larger than Planck and not really, really big, again, on universal scales. And so that does encompass quite a big range. But at any rate, so a Planck length compared to a strand of your hair is equal in magnitude to a strand of your hair compared to the size of the observable universe. And so right now those are just words, but if you were to get in a supersonic jet and fly around the Earth continuously, it'd take you about 32 hours to do it. And all of that planet that passed under you in that time could fit 1.4 million times over into the sun. Right? So you'd have to do that 32-hour trip 1.4 million times to go over the amount of matter that's in the sun. And I'm trying to give you an idea of the length of how big the observable universe really is. And you're moving at the speed of sound, by the way, in this example, which is faster than most commercial jets move, because if they move at the speed of sound, then they break the sound barrier and that shatters glass and there's problems there. So you're going faster than most commercial jets move, 32 hours around the Earth, 1.4 million times over, to get around the amount of mass that's in the sun. The sun is, in this example, about like 15 years away. If you were in a supersonic jet traveling, it's like 14 point something years away. And light takes about 8 minutes to move that far. So what we can travel going at the speed of sound in 15 years, light will do in about 8 minutes. And so with American units, that's about 94 million miles away, and that's called an astronomical unit. And if your brain can't really comprehend how far that is, you're not alone. Nobody really can. 1.4 million is just a huge number, and it's not, you can't really hold it, you can't really visualize it like you could 10. And that's okay. Don't beat yourself up over that. Nobody really can, but you can understand compounding. And so that's just 1 AU. That's just 8 light minutes. A light year is the amount of distance that light goes in a year, and that's way, way farther than the distance of our sun. It's incredibly far. And the observable universe is like 93 billion, with a B, light years across. And so a strand of your hair compared to the observable universe is equal to a strand of your hair, going backwards now, to consider the Planck length. So that's a huge range. And everything in that range is organized by these rules, or by rules. We don't know necessarily if we have a fundamental understanding what the rules are, but they're organized. So out of the stability of nothingness, a couple fundamental rules could kickstart this spectrum of, you can call it entropy-based complexity, that eventually leads to the manifestation of consciousness in the form of life. That's incredible. That is so incredible. That is like, what? It's like a miracle that the pattern of how things come together moved from, this baseless energy, which is called gluon plasma, to hydrogen molecules, which is the first stable, well, actually from there to quarks, and then from quarks to subatomic particles like electrons, protons, and neutrons, which are just names, by the way. Somebody just needed to give them names, and so they gave them electrons, protons, neutrons. And then from there to hydrogen, which is the first like stable combination of the three. And then from there, gravity attracting hydrogen together to make these huge gas clouds of hydrogen that, because of the density caused by mutual attraction in the core, begin to heat up and light on fire. And that's what a star is. It's a giant burning ball of hydrogen. And then inside of those giant burning balls of hydrogen, so much force and pressure and mutual attraction, forcing even more protons and neutrons into a nucleus to make all the other elements like helium and like lithium and every element. And then all of that being spat off into space in violent explosions for billions of years. And then that coalescing on like rock, like Earth, like orbiting balls, which again are orbiting due to gravity, that have this interplay with heat from this giant burning ball of hydrogen that they're orbiting. And just in Earth's case, then being hit by another ball, giving us a wobble, being pelted by an ice storm, giving us more water, being large enough for our own mass to not let us cool down like Mars did. So one of the reasons Mars lost its atmosphere was because the UV radiation from the sun baked it off. And the reason that it was able to do that is because Mars, it coalesced and was hot because it coalesced, and it cooled down. It wasn't large enough for its size to maintain the heat in its core, which is the fundamental part that leads to a magnetic field. So Earth was being bigger than Mars. We aren't cooling off the way Mars did, and so we have been able to maintain our magnetic core for much longer. Or magnetic field for much longer, which deflects this UV radiation, which is why we kept our atmosphere. So it's like, that's a level of complexity. And then past that, and this is all due to the interactions of like 4 to 5, let's call it under 10 so far observed patterns across 7 fundamental units like time, length, etc. And so that's incredible that, just energy created a playground that could manifest the complexity of just the Earth, much less life. The way that RNA and DNA work are literally incredible. And you and I are manifestations, from physics to, you can call it geochemistry, the way that the planet was orbiting without stereotypical life on it yet, and the differences in heat and magnetism, as we talked about, and all these things, the geochemistry that eventually turned into organic chemistry, that eventually turned into biology, that eventually iteratively evolved into complex life, or what we view as complex life, to be able to consider the environment that manifested itself in the first place. I mean, it gives you this sense of relativity that's like incredible. Like the fact that you can sit here and watch this video, and the fact that I can sit here and make this video is insane. It's insane. It's so miraculous. It's so undyingly amazing that it gives you this like sense of baffled wonder about just existence, that like even if life didn't exist, the fact that energy was able to coalesce the complexity that is, let's just say, the Milky Way or the solar system. I mean, it's beautiful. It's mind-blowing, and it's completely incomprehensible and we can gauge theories as to like why these things exist, but just the fact that they do exist and the fact that they are organized. I mean, life is such a testament to complex organization. It's a fascinating, beautiful thing. And so anyway, today I wanted to kind of share that viewpoint with you, because I take so much solace in just being amazed and fascinated with life and existence, and I hope you can too. And it really is just a fascinating thing, especially once you consider what the best human minds across time that have sat on each other's shoulders have been able to paint this picture of, and how it just kind of fits into the model that we already have. I mean, it's quite impressive. It's quite something. So if you guys like these types of talks, if you guys like these types of realizations, leave a comment or send me a message. Let me know. And because I have plenty of these, and they're not necessarily like inner peace advice as much as they are just like really kind of like wow, or at least I find them to be wow facts. And I'd love to do more of them if it's something that you're interested in. But that being said, any questions that you guys have, period, I'd like to answer if I can. And if I can't, I'll just let you know. Like, I have no idea. But here's like maybe my take on it. So because I really love the interacting. That's actually what spawned me making these videos, is that the interactions I have with people talking about topics like these, I always really enjoy them. So I'd like to share them with as many of you as possible. But at any rate, I hope you have a great day. I hope you're feeling a little bit more amazed. I hope you can take this type of mentality into your day. And yeah, have a good one. Peace.